Hi guys, I'm Jack. This is Cycle 6 and I'll talk about Chapter 7 and 10. So let's start with Chapter 7, Implementing DHCP. Okay, so what is DHCP? Before we get to the DHCP, let's talk about NAT. What is NAT? NAT is Network Address Translation. It translates the network address. And to use internet, we have to use router to get access to internet, and through that process, we can access to the Wi-Fi, which we use for our smartphone too. To do so, using internet requires our IP and receiver's IP address. So, that data packet can be transferred. Okay, so let's talk about DHCP. As we know, we are lacking of IP address because of the increased number of internet users. However, adding additional public IP costs a lot. Nowadays, even 6 years old kids are using smartphone. Just simple considering in Korea, they will need massive amount of IP address. However, if we have provided router by ISP, the problem will be solved easily. DHCP with one public IP address can make many IP, which means created IP can be used to connect internet. In addition, DHCP protocol is based on connectionless service model using UDP packets. Connectionless service do not guarantee transmission to destinations without a series of requests, permits, etc. for connections such as TCP. Okay, so DHCP uses the 4 messages between the client and server. First one, discover. It is sent by DHCP client to find a willing DHCP server. So the new host don't know about which DHCP server address is going to be used. So the host encapsulate the broadcast IP address and send to all nodes in subnet. Second, offer, sent by DHCP server to offer to lease to that client a specific IP address. Simply saying DHCP server broadcasts DHCP messages to client. Next, request, sent by DHCP client to ask the server to lease the IP version 4 address listed in the offer message. So it is just requesting DHCP to the server by the new host. Last, acknowledgement, sent by DHCP server to assign the address and to list the mask, default router, and DNS server IP addresses. The server is sending ACK message to check requested setting. So, 0.0.0.0, what does it mean in this chapter? It is an address reserved for use as a source IP version 4 address for host which hasn't got any IP addresses. We can say it is starting address. And 255.255.255, it is the local broadcast IP address. Packets sent to this destination address are broadcast on the local data link, but router don't forward them. So let's see how this works. This is an example between a host and DHCP server on the same LAN. As we learned, host will send the discover message to discover. With IP address of 0000, the reason why is it doesn't have any IP address yet. So it hits the destination 255.255.255 in LAN broadcast frame, reaching all hosts in the subnet. And the client hopes that there is a DHCP server on the subnet because 255.255.255 only go to the host in local subnet, or router 1 will forward the packet. And now what? The offer message here. Well, it's sent back by DHCP server. Why? The reason is host 8 doesn't have any IP address yet, so the server still can't send the packet directly to the host. So now, The server sends the packet to all local hosts in the subnet, which is 255, yes. Whew. The point is, all hosts in the subnet receive the offer message. Also, client ID includes the host MAC address. It can identify the original host. And now, host A knows this one. The offer message is meant for host A, and another host will get offer message. Supporting DHCP for remote subnets with DHCP relay. Cisco routers can act like DHCP server. Interesting. So distributed design can be used the router at each site as DHCP server. However, centralized DHCP server also has advantages too, because some Cisco documents suggest the centralized design as a best, because it allows centralized control and config of all IPv4 address. Interesting. And right now, while we're looking at this example of the process, so host A sites on the left as DHCP client, and DHCP server is on the right in here. Router 1 has an IP helper address 172.16.2.1.1. Oh, by the way, what is IP helper address? Let me explain it. So, it transmits UDP broadcast. Nice example. So, it transmits UDP broadcast, to other subnet. And in this picture, router don't spread broadcast, but what if the situation is like this? Workstation did broadcast to get IP, but what is DHCP server is another subnet with router. It cannot pass the router. IP helper address do the service that use these broadcasts to obtain or communicate information. Router receive the broadcast and transfer to the server. Okay, let's go back. So router 1 has IP helper address with G/0/gigabit, I think, interface, and router 1 knows the incoming DHCP packet is 425s, and step 2 shows the changed both source and destination IP address. It has been changed. And when router receives DHCP message to other router's IP address, the router knows the packet might be part of DHCP relay feature. If it happens, the DHCP relay agent needs to change the destination IP address. So host A in here, which doesn't have IP add yet, will receive and do its own job. Next one, information stored at the DHCP server. Okay, so some people understand DHCP server as a large piece of hardware. However, actually, that server could be the piece of software too, like other servers. It is made by software running on server OS. And such as big company install the stable and high available data center to support. This list shows the types of DHCP to support clients. First is subnet ID and mask. This is simple. The DHCP server can use this information to know all addresses in the subnet, reserved, excluded address. As we know, the server has to distinguish which subnet to not lease or lease. These lists make the engineer to reserve addresses to be used as static IP address. And default router, this is the IP address of the router on the subnet. And DNS IP address, list of DNS server IP addresses. So now let's check another configuration. This is with two LAN-based subnets, 172.16, 1.0/24, and 2.0/4. On the right, there's this DHCP server in here. So in this picture, the configuration reserves the lowest IP addresses in the subnet as static address. The interesting thing is, I found in the book is that configuration can set the time limit for leasing an IP address. So it means that when server leases an address, the client can ask to renew the lease. If client doesn't renew, the server can reclaim the IP address and put it back in the available IP addresses. And now, I'm going to talk about 3 allocation models in DHCP. First is dynamic allocation. This is the system-level computer process, also referred to as heap allocation or dynamic allocation. So it allocates the free segments of memory to be used by programs. Second is automatic allocation. It sets the DHCP lease time to infinite and allows DHCP to give a host a permanent network address, but still do it automatically without human interference. And static allocation. It pre-configures the specific IP address for a client based on the client's MAC address. And static allocation is very simple, but not efficient memory management technique. Next, configuring DHCP features on routers and switches. We know that Cisco routers and switches has various functions, so routers also can be configured to act as DHCP. Also, Cisco routers and switches can act like DHCP clients too, learning their IP addresses from a DHCP server. Configuring DHCP relay requires a simple decision and straightforward configuration command. We need to use IP helper address interface, and after that, to verify the relay agent, we can do show running config command or show IP as usual. So after we do show IP interface, they will look like this: helper address IP address. However, if there's no configured IP helper address, the text should show helper address is not set. Configuring a switch as DHCP client. As I mentioned, a switch can act like DHCP client to lease its IP address. We use IP address DHCP interface to figure out. So interface VLAN first, because a switch doesn't attempt DHCP until VLAN is up, and IP address, DHCP, and another picture. Looks similar, but this is verifying step. So this picture shows the interface VLAN output with IP address on third line. However, when using DHCP, this line only appears if DHCP succeed, which means we should be careful with this. So output list 192.168.1.101, but with no information to identify whether the IP address is a static or DHCP learned IP address. And this is the last step to check details of DHCP. We use show DHCP lease with temporary word. And we can see switch learns its default gateway with DHCP2. Perfect. And now, we will learn host setting for IPv4. So the host on the left is endpoint. It knows the address of at least 2 DNS servers for redundancy. So if the first DNS fails to respond, another endpoint can attempt name with next DNS server. So basically, if you want to communicate each endpoint to know the IP address of router in the same subnet, so the endpoint use router as its default router or gateway. In this picture, the host can forward packets to address outside the subnet to the default router. So the point is, whatever it is the host or default router, they have to agree to the addresses inside the subnet, meaning that the host will use the address and do the math to determine which is on the same subnet and on the other subnet. And the important thing is, if you want to check routing is working correctly, default router's address and mask should be in the same subnet and address. Okay, next chapter, chapter 10, network address translation. CIDR, okay. What is that? It is a global address assignment convention. It defines how the Internet assigns numbers authority, which is IANA. So CIDR in RFC 4632 has two main goals. First, CIDR defines a way to assign public IP addresses to allow route aggregation or route summarization. And those route summarize greatly reduce the size of routing tables. So basically it is an expression of the range of IP host. And it is very familiar to us because in IP address we see 192.168.0.2 like /24 like that. And like /24 is CIDR. So 255, blah blah blah. So it's like /32. Like we learned about this one. Private addressing. So not every computers are connected with the internet. Some computers hasn't connected with the internet, and these computers' IP address could be duplicated of registered IP addresses. So I get 3 routers and connect them in my house and config IP addresses in a network 1.000. And the point is the IP addresses I'm using might be duplicates of real IP addresses. And now we will talk about RFC 1918. It is also defined as private internet too. And this chart shows RFC 1918 private address space. We learned about this one in the class of networks, and this means any group can use this network and classes in here. But no organization is allowed to advertise their networks using routing protocol on the internet. Next is static net. So static net, the concept is kind of complicated. So the net router changes the source, which is SA in here, 10.1.1.1 to 200.0111 with static net. It is between private and registered address. So 10.111 is for private address and 200.111 is for registered address. So the terminology used with NAT. In this picture, the NAT lists the private and public IP address from the network 200.110. So in Cisco, there are two terms. Inside local for the private IP address, as this picture, and inside global for public IP address. Well, simply saying that NAT is network address translation, and IP addresses is with 32-bit, which means it is very limited. And that's why NAT is translating for static NAT. It is mapping one internal and external IP address one by one. And it converts a request to an external address to internal address and forward it to the inside. Okay, let's talk about overloading NAT with port addresses translation. NAT still needs a large number of IP addresses. So overloading makes NAT to scale to support many clients as previous example with few public IP addresses. So let's see the picture. So we see this picture. There are 3 TCP connections for only one PC. IP address and the receiving port numbers are same, but it seems like the server don't care about TCP connections from different hosts or the same host. So the great thing of NAT is that the server don't care about its connection. Look at these lines. If it is like one connection or 3 different host connection to single IP address. So PAT translates not only the address, they do port number if necessary too. And the last one, is going to be NAT overload configuration. Sorry, but I really have to use like this big one to explain it. So as usual, we do the show command, show running config, and there will be lists for us like this. Let's see. So the IP NAT inside source command has several parameters. The list one parameter means the same thing as dynamic NAT. And interface 0/0/0 in here means only inside global IP address available is NAT router's interface serial 000. And overload means overload is enabled. Easy. So we see 3 translations have been added to the NAT table, and host 10.1.1.1 creates one telnet connection to 170.111, and host 10.1.1.2 creates 2 telnet connections. Means that the router creates one NAT table entry for each IP address and port. And this is my source that I used. And thank you for watching.